we can start by highlighting this. What's interesting in chapter 5 is there's going to be a lot of formulas that we need to use, and none of them are on your formula sheet, which sounds super scary, except they made a rule where they said they want to use so many different formulas, it would take too much room on the formula sheet. So instead, whenever they ask you a question on the exam, they'll give you the formula in the question. So you don't have to memorize any of these formulas, but there are a lot of formulas that involve exponential functions. One of them is compound interest. So the way that compound interest works is as follows.
It's the best of the bench, like everything.
So they're taking a certain amount of money and they're saying if you got 2% annual interest, so whenever they give you compound interest, they tell you the interest rate and they tell you how often it's compounding. If it's compounding annually, this is how it would work. You have $100, and at the end of the year, 2% of $100, so, right, end of year is 0, you start off with $100. End of the first year, you would get $2 more, because that's 2% of 100. Then at the end of year 2, you make now 2% on the $100 again, which will give you another $2, but you also make 2% on the $2 you already earned. So you would have $104, and 2% of $2 is 4 cents. The 4 cents is your compound interest extra that you got. If it was simple interest, you would just get $2 every year. But the compound interest says you're going to get $2 for the 2%, plus now you start making interest on your interest. And over time, compound interest can mean that your values go up a lot. But not very much in this case, because technically, our equation for this is we started with $100. Our interest rate is 2%, which is an R value of 1.02 to the X. That 1.02 says it's increasing. It will have this shape of the graph, right? Exponential graphs look like that with an asymptote. It will get really steep sometime in the future, but it might just take a long time before it gets there. Because the 1.02 is not very much bigger than 1. It takes a long time for it to increase. But if you waited another year, you would now have 2% on this, which would give you $6, and an extra, well, 2% of that, 8 cents, and then extra, I guess, we could go to decimals and figure out the 2% on top of that. But slowly, the little bit extra is adding up. And this is what makes it compound interest. And the more time something is compounded, the more money that you're going to get. So they've given us a formula for this. Let's see where it is. Yeah. And this formula often shows up on exams. Often they have P instead of A0. Sometimes they have R instead of I for interest rate. N is the number of compounding periods, and T is the time in years. So not only, if they ask you a compound interest formula, will they give you the formula, they will also have to explain what each letter stands for. So it's really nice on the exam, because if you had the formula sheet, you'd have to remember what each letter stands for. But on the exam, they will explain what each letter stands for. And because this little part here is bigger than 1, your money is growing. We call that the growth factor. Okay? And whenever you have something where it's growing, we call that exponential growth. Sometimes we have things that are exponential decay. So at this point, we're going to just look at how do these questions work. And the textbook doesn't give us a formula, but you would have been given this formula or some form of it and had things explained. So a principal of 1,500, so the 1,500 goes in for the initial amount, invested at 4%, and even on the exam they will tell you that R is the interest rate as a decimal. So the formula would tell you that it's as a decimal, so you would know to change the 4% to 0.04. Compounded quarterly. This is something that can be hard on the exam. They won't tell you. They'll say that N is the number of times that it's compounded per year. But you have to know special words like, do you know that quarterly means 4 times a year? Most common one is monthly. Monthly is how many times a year? 12 times a year. Tricky ones, last year's exam had semi-annually. Does anyone know how many times a year semi-annually is? Twice a year. Right? And then when you buy your own mortgage, sometime you might, or when you have your own job, some jobs pay weekly, some pay bi-weekly, every 2 weeks, some pay semi-monthly, twice a month. So if they said that you're being paid bi-weekly, how many times would you get paid in a year? Do you know how many weeks are in a year? 52. So if you were paid every 2 weeks, you'd be paid 26 times in a year. So sometimes this part, quarterly, monthly, semi-annually, and annually are the ones that come up the most. Semi-annually being twice a year, annually once a year, monthly 12 times a year, quarterly 4 times a year. So since it's 4 times a year, the N would be 4, and T is what we don't know. But we know the final amount is 2,500. And unfortunately, later on you're going to be able to solve this with scientific calculators. Currently, we don't know how to do that. So all we can use is either Desmos or a graphing calculator. Either one, what you're going to do is you're going to type one side into one equation, the other side into the other equation. So I'll show you with the graphing calculator. It would be the same thing in Desmos. Desmos might even be a little bit easier. I can show you on both. Because you have some. So we take the one side, which was 2,500. We take the other side, which was 1,500 bracket 1 plus, you can use the fraction button if you like, 0.04 divided by 4 to the exponent of 4x, because there's no t button. So we type in the two equations exactly as we see them. If you have an older calculator that doesn't move the exponent up, you'll need to make sure you put it in brackets. If it just gives you the little hat button, we need to make sure that we put that in brackets. Now, normally when you hit graph, you'll probably be on a standard window. So I'm going to just zoom 6. This is the standard window. It really is not very helpful in this question. Yeah. Do you see where the two graphs intersect? We have a problem. We have a problem because, well, y equals is a horizontal line. That line's going to be at 2,500. Are you surprised we didn't see it from minus 10 to 10? No. So I'm going to go to my window button, and I'm going to go for a y maximum. I'm going to go to at least 3,000. And then I should be able to see that line. And the red line is like getting so close to intersecting. We need to find out where they intersect. So I think if I change my x max to 20, I think I'll see it. And if the two graphs intersect, we can go second, calculate a value. No, we want number 5, the intersection. Push enter on the first curve, enter on the second curve, enter when it says guess. And 12.83. quarter of a year. But before this, I might show all of, it's really good habit on the exam to show 3 decimal places without rounding, put a little dot, dot, dot there, and then round afterwards if necessary. So we always have to do 3 places. Graphing calculator, should I go over that again at all, or is everybody okay?
We don't need it for the test, right?
You don't need it you'll need it for take-home quizzes. And on take-home quizzes, you'll either be able to use your graphing calculator or Desmos. But I'll take it off your test, because your exam doesn't use a graphing calculator. So when we get to this question, it'll be a scientific calculator question, and we'll learn how to do it with logarithms when we get it. Brooklyn, you have a question? Just like here.
Wait, how do you round it?
The window part?
Like, no matter how high I make it, it still doesn't work. Like, I've tried everything from low to high numbers.
I think the problem here is your minimum is bigger than your maximum. So that's why sometimes you don't see that, and then it gets confused. So try that. I'll go to Desmos here. Did it work? Still having problems? I'll come check it in a second. I'll do the Desmos part quickly first. So we can go y equals, in Desmos you have to write y equals, and y equals 1500, 1 plus 0.04 divided by 4. You have to use the little hat button to do the exponent, and then it was 4x. Again, none of these graphs show up. Might have to scroll way out. Oh, there's one graph. I know that I'm going to have to see 2500. Now, as soon as I click on there, click on one of the graphs, the dot where they intersect is like, you probably want to find this. These are things people like to find. It shows up, you just have to click on it. We get the 12.834, the same as before. Let's see if your window is working for you. Okay. Well, Y max you'll want to go up to, because it's at 2500, you want to go up to 3000.
That's what
Now let's see. One of the things that I like to do on my window, I like to keep one major, so then you can see the axes. Gives you at least a perspective. So let's figure out the there's one is the other one, 2 straight lines, makes it sense. That maybe so we know the answers. We're just going to do so basically what I'm hearing. I think I know what my math is. Let's see. There we go. Little things like that can cause the calculator to change its mind. Okay, so that's a calculator question. You have on your take-home quiz a calculator question where this will be the strategy. Either in Desmos or in a calculator, plug this into one side, this into the other, and find out where they intersect.
That rounding doesn't make sense.
It says to the nearest.
But you wouldn't get 2500. So then you should be wrong.
Yeah, okay. So this is sometimes they would probably on an exam accept both of these.
Oh, okay.
Because this is rounded correctly, but you haven't hit 2,500.
500, right.
This is rounded incorrectly to the nearest quarter, but you would for sure hit 2,500. So sometimes in word problems,
Yeah.
that interpretation comes into play.
Okay.
Okay, questions? Do you want to practice your graphing calculator or Desmos? Circle question 12 and 13.